A special morning to Trevor. Trevor, this is especially for you. I'm going to explain in chapter 6.1. Please turn to page 273, number 17. Now the instructions there is that we have to graph these two equations in order to find the solution if there is one. Okay, so I have these two equations. They're part of a system and we're going to number them. This one is number 1 and this one is number 2. I would like to graph them, but as you can see, they are not in slope-intercept form. So first I have to rewrite both of them in order to get them into slope-intercept form. So here we go. The first one, I have to take the 3x to the other side. So I have y, and if I have to take the 3x to the other side, let's just go back here. Then I'm going to say minus 3x here, minus 3x there. Goody. So here I'm going from there to here. Y is equal to 5 minus 3x. Alright, but we want to write it in proper slope-intercept form. So we're going to say 3x, it's minus 3x plus 5. And that is our first equation, ready to be graphed. Okay, now we're going to go for the second one. And the second one is even easier because I can just take the x to the other side. So let's move this one down here. We can do the second one here. I have to just take x to the other side. So minus x on this side, minus x on that side. And here we go. I'm going to say minus y is equal to 7 minus x. Only problem is that my y is now negative, and we know that y should never be negative. Okay, so we're going to multiply right through with negative. Okay, so multiply with negative right through, so this becomes positive, that then becomes negative, and that positive. So let's write it properly. We're going to say y is equal to x minus 7. Okay, now this little guy is also ready to be graphed. And now I'm going to move over to this side. My wonderful cameraman Misam is going to focus here. Thanks, Misam. And we're going to do the first one. We're going to go to 5, which is on the y-axis. I have 5, 1, 2, 3, 4, 5. Okay, good. Now I want to go for the slope, which is minus 3. If it's minus 3, we all know that it's 3 over 1. Okay, so I'm going to go 3 down because it's negative. 1, 2, 3 down, and then 1 across, which is right here. And that is our first line. Let's draw the first line. And I'm going to draw it in red so we can see it clearly. I hope it comes out well. Okay, there's our first line. Now we want to go for the second one. Okay, I haven't got enough increments here. I'm going to have to add some because I'm going to go down to minus 7. Let's go down. Remember, the more accurate you are with these, the better your answers are going to be. The closer to the real value your answers are going to be. So, you have to be accurate. 1, 2, 3, 4, 5, 6, 7. I'm down at 7. Okay. And then I look at my slope. And if it's just x, it means it's 1 over 1. So there was 7. So I'm going to go up 1 and 1 to the right. There's my first point. There's the second one. Okay, and I'm going to graph. Alrighty, now this is an interesting one. Seems like I have to just extend this line slightly to see where they cross. Alright, now I've done the two graphs, and that was straightforward, easy, isn't it? And now all I need to do is I need to go and check where do they cross, because where they cross is the solution for both this graph and for that one. Okay, so we're going to see what is the solution here. We can see that x is 3, and we go down here, we see y is minus 4. So there is one solution to this problem, 3 and minus 4. And to be 100% sure, I can take these two values and I can go and plug it into either or both of these two equations. I'm just going to pick the second one because it's easy. I'm going to plug these two values into the second one. I'm going to look down here. X minus y is equal to 7, and I'm going to plug in the value for x, which I get here, that's 3, and the value for y, which I get here, that's minus 4. I plug it into the second equation, alright, and I'm going to see 3, and then minus times minus is 4, that's equal to 7, 3 plus 4 is 7, 7 is equal to 7. Now usually I would call this an identity. Now an identity means that the value for x and the value for y that I have is indeed a solution for this equation. And if I would have plugged it in there, I would get the same. So it would also be a solution to that equation. So do you see that by graphing, I could find the solution for both these equations? That spot where it crosses is the solution for both equations. Nowhere else would be a solution for both equations. I can pick a point there and plug it into both equations, and it will not make the second equation true. I can pick a point on this line, and any point on this line other than there would be a solution for the other equation, but not for the first one. So this is the only point that is a solution for both equations. Okay, and that brings us to the end. This is an example with one solution. The solution is 3 and minus 4. Thank you.